Right now, you are going blind for tiny moments. Not once, not rarely. Every few seconds, each time your eyes jump, your brain suppresses part of what you see. Then it quietly stitches the world back together, so reality feels smooth. And the strangest part is this. You can almost never catch it happening. Look around the room. It feels like your vision is a steady video feed, a continuous stream, like a camera recording the world in front of you. But your eyes do not work like a calm camera. They work more like a frantic photographer. Snap, jump, snap, jump, snap. Your eyes are constantly making tiny rapid movements called saccades. A saccade is a quick jump from one point to another, from this word to that word, from a face to a lamp, from the road to a sign. Most of the time you do not feel these jumps, but they are happening constantly. Depending on what you are doing, your eyes may make several saccades every second. And during each jump, something weird happens. Your brain turns down your visual sensitivity. Not completely, like someone switching off a light, but enough that the blur from the eye movement mostly disappears from your awareness. This is called saccadic masking or saccadic suppression, and without it, the world would look terrible. Imagine taking a video with a camera, but every half second you whip the camera to the side. The footage would be a mess. Blurry streaks, smears, motion trails, chaos. That is what your eyes are physically doing. But that is not what you experience. You experience a stable room, a stable screen, a stable world. So where did all the blur go? Your brain edited it out. Here is the mystery. If your eyes are moving so often, why do you never see your own eyes move? Try this safely in a mirror sometime. Look at your left eye, then look at your right eye. Your eyes must move. They have to cross that tiny distance, but you will not see the movement. Your gaze seems to teleport. Left eye, right eye, no travel in between. But if someone else watches you do it, they can see your eyes flick back and forth. So the motion is real, you just do not get to see it. That is saccadic masking in action. Your brain is hiding the messy transition. But it gets even stranger. Your brain does not only hide the blur, it also helps create the feeling that time and space stayed continuous. One famous example is the stopped clock illusion. You glance at an analog clock, and for a split second, the second hand seems frozen. Then it starts moving normally. It can feel like that first second lasted too long. This illusion is called chronostasis. One explanation is that when your eyes jump to the clock, your brain fills in the missing moment by making it feel like you had already been looking there. So the first tick seems stretched. Your brain is not trying to trick you for fun. It is solving a serious problem. Your eyes are unstable sensors mounted on a moving head, attached to a moving body, walking through a moving world. Somehow, your brain has to turn all of that into a useful picture. If it showed you every raw signal, you would not get a clean movie. You would get a shaky blur with interruptions. So the brain does something smarter. Before many eye movements, it predicts that a saccade is about to happen. The movement command that tells your eye muscles to jump may also help inform visual areas of the brain. Basically, the brain gets a heads up. The eyes are about to move. Ignore some of the messy input. Then, after the jump, the brain uses the new information to update the scene. This is one reason the world does not appear to slide across your vision every time your eyes move. Your brain keeps track of where things are supposed to be. Not perfectly, but well enough that you can read, walk, catch a ball, and recognize a friend across the street. Think of it like editing a video. A bad editor leaves in every shaky camera swing. A good editor cuts from one important view to the next. Your brain is the editor. Your eyes collect the shots. Your attention chooses what matters, and your conscious experience receives the finished cut. This does not mean your brain is making everything up. That would be too simple. Your brain is using real information from your eyes, but it is not giving you the raw feed. It is giving you a process model of the world. A useful version, a stable version, a version that lets you act quickly without being overwhelmed. This is also why vision feels much richer than it really is. You may feel like you see every detail in front of you at once, but your sharpest vision is concentrated in a tiny central area of the retina called the fovea. Hold out your thumb at arm's length. Your sharpest detailed vision covers only a small region, roughly around the size of your thumbnail. Outside that area, your vision is less detailed. You still detect motion, shapes, colors, and general layout, but fine detail drops off fast. So your eyes jump around to sample the important parts. Face, door, text, movement, food, danger, friend. Your brain combines these samples with memory and prediction. The result feels like a full, detailed world. But in reality, your visual experience is built from selections. Your brain is constantly asking questions. What changed? What matters? Where should I look next? What can be safely ignored? Saccadic masking is one answer to that last question. The blur during the jump can be ignored. The stable information before and after the jump matters more. This is not a flaw, it is a feature. If you noticed every saccade, every blur, every tiny gap, normal life would become exhausting. Reading would feel like watching words smear across a page. Walking through a grocery store would feel like a broken camera feed. A simple conversation would be filled with visual jumps from eye to mouth to hand to background and back again. Instead, your brain gives you continuity. It hides the cuts, and it does it so well that you usually need a science video to find out the cuts exist. But there is an important limit. Saccadic masking does not mean you are helplessly blind all the time. It does not mean your brain fully shuts off vision. And it does not mean reality is fake. It means perception is active. Your brain is not a window, it is a builder. It builds your experience from light, motion, memory, attention, and prediction. Most of the time, this works beautifully. Sometimes it creates illusions, and those illusions are useful because they reveal the hidden machinery. The mirror trick reveals the missing eye movement. The stopped clock illusion reveals time stitching. Change blindness reveals how much detail we miss when attention is elsewhere. Together, they point to the same surprising truth. You do not experience the world exactly as it arrives. You experience the world after your brain has cleaned it up. So the next time you look from one object to another, remember what just happened. Your eyes jumped, the image blurred, your brain suppressed the mess. Then it handed you a seamless reality and acted like nothing happened. You are not watching life as a smooth video. You are watching the brain's best edit, and the editor never shows you the cuts,